Formula b squared minus 4ac. All right, straight out of last unit. Now, the rest of it is just kind of a blurb as to what it applies to, but I just realized that we're missing a bullet point here. There's positive discriminant value, positive and perfect square. It's supposed to be an and symbol. All right, and then positive and not a perfect square. There's a fresh new typo for somebody. So positive and perfect square, positive and not a perfect square. The positive perfect square was the case of having two real rational roots. All right. Now, we talked about roots in the last unit as some kind of nebulous thing, like it existed, but what were they? In this unit, we learned that roots are the same as x-intercepts. All right, so two real rational roots or two real rational x-intercepts. The case of positive and not a perfect square would be two real irrational roots. All right, two real irrational roots. The negative case was the nice one, or at least it was in the last unit. It meant that there were no real roots. You just couldn't get an answer. No solution is what we went with. All right, but it means something different here. Slightly different, but no real roots is the standard response when you have a negative discriminant value. Got kicked out of the Wi-Fi for some reason. The zero discriminant value was one real root, one real rational root. All right, and again, roots, x-intercepts mean the same thing in this context. All right. So, excuse me. What we want to be able to do is reconcile our knowledge of discriminants with our knowledge of what a parabola looks like. All right, so basically, the first two bullet points are going to involve two x-intercepts. They may not be pretty, but there will be two of them. So two x-intercepts. The case of no real roots would be no x-intercept. And the case of one real root would be one x-intercept. Right? So, you look at the diagrams below, you could identify which category the discriminant is going to fall into based off of just the appearance of the graph. Like the first one has one x-intercept. So the discriminant must be equal to 0. My handwriting was bad enough before spring break, but not having written on a device more than like once in the last week and a half has really done a number on me. All right? So just bear with me on that. The case of, like number 2, for example, I see it doesn't cross the x-axis at all. All right? So we're looking at an instance where the b squared minus 4ac value, the discriminant, would be negative. So less than 0. The last two are the weird ones. All right, because they're the the ones where it could go into one of two categories. In both cases, b squared minus 4ac is going to be positive. But in one case, it crosses through the axis cleanly, and in the other case, it doesn't. All right? So when it crosses the x-axis cleanly, that is consistent with a rational root. All right? So we know they'll both be real roots. One case will be irrational, the other will be rational. So the case of irrational would have to coincide or correspond to a discriminant value that's not a perfect square. So, and not PS for perfect square. The last one crosses through cleanly, so that one would correspond to a discriminant value that is a perfect square. All right? So what we need to do is match these graphs with the discriminant. Now, what we'll ultimately be doing is matching the discriminant to an equation, to the graph, you know, among those three things, but got to start somewhere. All right? So really, this is mostly computation, because you're just kind of looking at it and saying, all right, well, what is this discriminant value? They gave us the numbers. Is it going to be a positive perfect square, positive not a perfect square? Is it going to be negative? Is it going to be zero? All right. So with a calculator or in your head or whatever, you'd figure these out. Now, these aren't too bad. The numbers are kind of nice. So I'm just going to work it through. Negative 2 squared is a positive 4. Minus 4 times 1 times 2. 4 times 1 times 2 is 8. 4 minus 8 is negative 4. So that's a negative number. Spoiler. So the case of a negative number is question 2, I guess, is how I'm phrasing it. But 2 and A match. All right, 2 corresponds with A. All right, because that's the one where it doesn't cross the x-axis at all. All right. And I could show you really quickly. I don't want to make this a lesson about Desmos. I would like to make it a lesson about how to open an app. Jeez Louise. I don't even know a Louise. Okay, for whatever reason I can't do it that way. Maybe I'm just not moving swiftly enough. But let me open Desmos real quick. So I'm just going to pop in an ordinary quadratic. F of x equal to ax squared. Probably better off I do it this way anyway. Easier to type. So this is what an ordinary parabola would look like, you know, just with coefficients of 1. Right? This one does not cross the x-axis, so you would expect its discriminant to have a value of some kind of negative number. So I would just put in b squared minus 4ac, and you see that it returns a discriminant value of negative 3. Now if I tweak it so that it crosses the x-axis, you notice how the discriminant value goes from negative. I don't think I'll ever quite be able to get it to land on a 0, but at some point there is a point where it would just touch the x-axis, but I don't think I'm dexterous enough to get there. But yeah, there would be that moment. But then once it goes through, it goes from being a negative discriminant value to a positive discriminant value. Right? Now, whether it's a positive perfect square or not is, you know, kind of besides the point for this demonstration. Here's a case where it's a positive perfect square, and you see that it crosses the x-axis in 2 nice, convenient locations. All right? So that's the idea behind it. You're able to determine the nature of the graph just by the function, or determine the nature of the equation based off of the graph. All right? Either way, it's good information. All right? So the next one, negative 4 squared is going to be positive 16. If I get my pen to work. I got 3 negatives multiplied. That's going to give me a negative result. 4 times 1 times 4 is 16. Gives a result of 0. All right, the case of 0 is the case where it intersects the x-axis only once. So b and 1 correlate or correspond to one another. This one for C has a 0 in it, so it's really just a negative 4 squared, which is positive 16. All right, so that's a positive perfect square, so 4 and C match. And then, process of elimination, 3 and D, but I'll just do the math real quick. Get a fresh new color here. We're looking at 64, 3 negatives, so minus 4 times 1, well, that's obviously 4, times 13 is 52. So we're getting a 12 as a result, positive number that's also not a perfect square. All right, so D and 3 correspond. All right. So then numbers 5 and 6 are actually pretty easy because we don't even need to do any math here. Determine the number of real solutions, aka how many times is across the x-axis. All right, so one real solution, one real root is what we would say. The Regent says solutions, I don't like that. 2 real roots. And if the value of the discriminant is positive, negative, or 0, well, if there's one real root, then the b squared minus 4ac value must be equal to 0. If there's 2, then the b squared minus 4ac would have to be greater than 0. It didn't ask us, like what kind of roots they would be, as in rational or irrational. Just said how many are there, and what does it say about the discriminant. So I don't have to say positive and perfect square. Although if you throw in perfect square, not perfect square, in this case it would not be a perfect square, then you're not wrong. But anytime you throw in extraneous information, there's a danger, because if it's extraneous information that's irrelevant, well, that would be the definition of extraneous information. If there's extraneous information that's correct, it becomes irrelevant. If there's extraneous information that's incorrect, so information that you didn't need to put down on paper for a test, you put it down anyway, and it's wrong, now it just became relevant. All right? So you presented something for assessment. All right? So if you put something down that's unnecessary and it's wrong, you're going to lose credit. All right? So here they did not ask if they're rational or irrational, so don't answer the question that wasn't asked. All right. For number 7, doesn't cross the x-axis at all, so no real roots. All right, that would be the case of b squared minus 4ac being less than 0, aka negative. And then number 8, we're back to square one here. It's the same answer as number 5. It appears to only touch the x-axis once. So one real root, the b squared minus 4ac has to be equal to 0. Something else that I guess you should be mindful of, but I can't see how it would be an issue. Sometimes it could look like the parabola only crosses the x-axis once, but if you really, really zoom in, it might cross more than once. Show you a quick example. Basically this example. So right here, it looks like clearly, I would say, 2 intersections. But if I zoom out a lot and show you a graph that looks like this, same graph, at first glance, it might look like it's only crossing once, right? But since the Regents is a pencil paper assessment, it's not like you're going to be able to zoom in on the paper. So if it looks like it only crosses once, it only crosses once. But sometimes it could be deceiving, right? Because if you really, really bring it in, you see that there's more than one intersection there, right? So those kind of things you got to be careful about. But like I said, on a pencil paper assessment, it's not going to be much of an issue. All right. So what I'd like you to do, so we're gonna skip page 13 because honestly, I don't know why it's here. It's really supposed to be in the last unit. So I'll take that as a typo too. But what I'd like you to do is page 14. All right. Again, just like last week. I'm not going to ask you to submit anything, but just just do it because we're going to go over it tomorrow, and that'll kind of lead us into where we're going next with this unit, which would be, because in terms of the raw skill, we've pretty much covered everything. We've learned all the aspects of a parabola, how to graph them, what the important parts are. Now we're going to learn how to apply them. All right, so to some that might mean word problems, but it's going to be applications. We're going to do a project. All right, so you want to make sure that you have this down. Right, so the rest of the period is yours to bang this out. It actually shouldn't take too long, so you might have some time at the end. Nice, easy day back, I think.